So in this lecture we are going to see about sequential logic circuits. So we have seen combination logic circuits in the previous lectures. I'll give the link in the description so you can see. And the combination logic circuits, they are very simple. We have a logic circuit here, and there will be an input given to you, input, and you'll get an output, right? So the input, right, it is controlling the output directly. That means the output is purely depending on what is there in the input. If there is a change in the input, there will be a change in the output, right? So this is for combination logic circuits. Here in sequential logic circuits, we have an extra element connected. So it will be looking like a feedback, which we have studied in control systems. So this will be connected directly to the logic gates, right? This is the logic circuit, LC, right? LC is made up of logic gates, right? So this extra element here, right? So connecting this extra element, right? What does it make a change here? So this is nothing but a memory element, right? So a memory element. Right. See, for example, if you are counting from 0 to 10, right? So you will be starting with 0, right? 0 plus 0 equal to 0. That is 1. If you want the output 1 here, right? You will be adding 0 plus 1, right? And if you want to have the output 2, right? So the the increment is 1, right? Increment is 1, but the number 1 should be there in your memory. Right? In the schools, you have studied that one in the finger and one in the mind, right? One in the mind represents your memory. So the previous state, 1 should be there in the memory, and plus 1 is the increment, and you will get the output 2. And if you want to have the output 3, and the increment plus 1 is default, right? So the number 2 should be there in your memory, right? So that you can add this plus 1, right? The operator plus 1, and you get the output 3, right? Similarly, if you want to get the output 999, right? You want this output, and the increment is default is plus 1, that but the number 998 should be there inside your memory, right? So that you can access the memory and add 1 to it, and you can get 999, right? So this memory element is very essential and very important, right? Adding this memory element converts this combination logic circuit into a sequential logic circuit, right? This memory element you connect here is nothing but what you call is a flip-flop, right? So flip-flops, in general, we have 4 flip-flops used majorly in digital logic circuits. That is nothing but a set and reset flip-flop, right? First one, and second one is a JK flip-flop, and this T flip-flop or toggle flip-flop, right? Toggle flip-flop, and the last one is D flip-flop or data flip-flop or delay flip-flop, right? So these are the 4 types of flip-flops we use here, right? So we'll see one by one flip-flops in the coming lectures, and now we'll go back to this block diagram here, and the sequence logic circuits here given with here, right? There are 2 types, right? First one is a synchronous sequential logic circuits and asynchronous sequential logic circuit. So the synchronous sequential logic circuits and asynchronous sequential logic circuits both have something in common. That is, see, for a sequential logic circuit, the output, the present state of the output depends on what is there in the input and what is there in the memory, right? Unlike combination logic circuits. Combination logic circuits, they don't have memory, right? So you don't have to bother about the memory element. But if you come to sequential logic circuits, right, the output, the present state of the output depends on what is there in the input and what is there in the memory element, right? So based on this, right, how you are giving operating this memory element, right, it gives two types of sequential logic circuits, and one is synchronous and the next one is asynchronous.